This video is still explaining graphing radical functions. The two things we're going to do on this one is solving a radical equation by graphing, and we're also going to be rewriting a radical function from the original so that we can find the function notation. So this first one, we're going to solve this radical equation by graphing. It says the population of Corpus Christi, Texas between 1970 and 2005 can be modeled by the function p of x equals 75,000 cube root x minus 1950, where x represents the year. In what year was the population of Corpus Christi 275,000? The question is asking in what year, so we need to know what x is. So in what year? X represents the year, so that means that we don't know our x. But we do know our y value. Now, again, p of x, this really represents our y value. We actually do know our y value, which was our population, which is 275,000. So our 275,000 is our y value. Now, in order to do this, you really want to have, we have the equation, but we do know our y value. We don't know our x. So what we do is plug in our y value that we do in fact know and set it equal to the equation. So we actually have 275,000 equals to 75,000 cube root of x minus 1950. Now the reason we want to do this is because if we have an equation, we can solve it in our calculator by graphing them, by just putting this into y1, the first one into y1, and the second one into y2. And then we find the intersection of it. The problem is that we have such large numbers that we need to figure out the scale that we're going to use. Now, we know that x is supposed to be years, so we're going to write that x is years. X is years. We know that the y is supposed to be our population, so y is population. You might be wondering why we don't have a full coordinate plane. Why is it only quadrant 1? This is a real life problem. So in years, we can't go back in time, and we also can't have negative years. So our first year of 0 is between 1970 and 2005. So technically 1970 is year 0. Then we also can't have a negative population. So population, it can go down to 0, but it technically can't go down into the negatives because you can't have negative population. So that's why we technically only need to focus on quadrant 1 because none of the other information would make sense. So what we want to do is when we graph this, we need to make sure we have a correct window to only focus on this information. Because if I were to graph this, if I go into my calculator, if I go to y equals and I graph, I want 275,000 in my first one, 275,000. And then my second one, I want the original function, so that's I need to do the cube root, so 75,000, math, the fourth cube root, and then x minus 1950. Now the 1950 should be the year, 1950, or 1950. So then if I press graph, it's loading. Still loading, but it never shows anything because I have such large numbers. Now, zoom fit would fit the graph, but it will distort your graph. Now, this is already rectangular, so it's already pushing it sideways more, so it's already kind of distorting it. So what we want to do, instead of looking at our zoom fit to fit the graph, we actually want to see the graph in our window. So we're actually going to change our window. X minimum, that's the years. So technically we can have minimum of 0 years. We press 0. Then for our X maximum, so the maximum amount of years, let's say, so 2005 would be between 1970 and 2005. So let's just go ahead and we can put more than 2005. Let's do like 2,500 as a precaution so that we can actually see the graph. Now this next one says X scale. Now I don't want to count by ones because then I'd have 2,500 little tick marks. So instead, if I count by maybe 100, then I'll have 25 tick marks, because that's every 100 I'll have a tick mark. Now the y's are your population, so minimum population obviously has to be 0, because you can't have negative population. But the maximum population, we want maximum. Now we already want to know when it hits a population of 275,000. So what we can do here is, so that we can actually see most of the graph, we could increase that 275,000 to maybe 300,000. So that we can actually see more than just the 275,000. We can actually see where it crosses, but then we can see more. Now again, I don't want to count by ones. We actually want to count by, maybe, if we count by 1,000, we still have 300 tick marks. Maybe if we counted by like 20,000, that might be better. So 20,000. And then when we press graph, we'll be able to see something. So here's our 275,000. That's the population we want. And then there's our cube root of 75,000 cube root of x minus 1950. 75,000 cube root of x minus 1950. Looks like that. Now this is kind of weird. So if I look at my other calculator, it might change, it might look different. So if I do 275,000, and then I have my 75,000 math 4, then I do that x minus 1950. Then I go back to my window, I do 0, 2,500, count by 100, 0, 300,000, count by 20,000. Then I'll press graph. Let's see what happens here. There's the 275,000. And then there's that cube root part too. Now the thing about the cube root part is that you actually do know that the cube roots from the other videos will actually keep going this way. It's just being a little weird on that graph. So on here, we can actually somewhat graph that. So we have that 250,000, or 275,000, sorry, comes right here. We know it's gonna keep going. And then we saw the cube root kind of funky right here. Right there. But you know that it's supposed to kind of go like this. And it's supposed to go like that. So we want to find this solution right here. So since we have our graph, we can do second trace 5. Go over to that intersection. And then press enter, enter, enter. So it looks like in the year is 1999, we're going to have 275,000 people in Corpus Christi. So that coordinate is roughly 1999, comma, 275,000. So that means that in 1999, we'll have that population. So I'm going to put that note down here about the change of the window. Change the window. Because if we didn't change the window, we would never have been able to have seen any of this. So our X minimum, the year, was 0. The X maximum for the year was, we did about 2,500. The X scale, that's what we're counting by. We decided to count by 100. Then the population Y minimum, we know has to be 0 because we can't have negative population. And then the Y maximum, we went up to more than 275,000. We went up to 300,000 so that we could see more information. Then our Y scale, we couldn't count by 1, so we counted by 20,000. And then we didn't do anything else from that. The last part of it, we didn't have to do anything with. That X res, we didn't do anything with that. And we found the solution. We found the second trace 5. So once we had those, we did second trace 5. And we got our intersection at 1999 and 275,000. So we can say, so in what year was population of Corpus Christi 275,000? So we can say in 1999, the population in Corpus Christi, Texas was 275,000. So again, that is an approximation as well, because it was 1999 and a little bit of change. That might have been in a different month. It wasn't exactly in the very beginning of 1999. It could have been in like January or February. But you can still find it using second trace 5. It's just really understanding how to use the window. That's what that problem was mainly about. This problem, rewriting a radical function, is how can you rewrite the cube root of 8x plus 32 minus 2 so you can graph it using transformations. So describe the graph, then sketch the graph. Check your results with the calculator. What that means is we want to figure out the transformations. We need our a, h, and k. So on here, our a value is supposed to be on the outside. Our h value is supposed to be the inside. Our k value is the outside. So for these, we have to focus on the inside for our h value. So we have, for the horizontal, for our left and right horizontal, we want to take the horizontal is always from the inside, but we always had to change the sign because it was change h, but we also have something else attached to it. There's something else attached to it. So technically what it is you have your 8x plus 32 has to actually be equal to 0 because we need to figure out what that value is. So when we solve this, we'll have 8x equals negative 32, then x equals negative 4. So if the x is negative 4, that means it's actually going left 4. So h is equal to negative 4. Our k value, the vertical part, is our k. That's always the outside of it, and it's still just minus 2. So what that means is that it's still just down 2. So our k equals negative 2. What we're really missing is our a value. Because we had to do something funky with our h, that means that there's something probably weird with our a value. And actually, you could have done this before you did this part. We could have found our a value first. So for our stretch, or compress, whichever one that is, stretch or compress, that's our a value. We have the cube root of 8x plus 32, which if we look at this part just itself, you can see that you can factor out an 8 from both of those. So it could be written as the cube root of 8 parentheses x plus 4 parentheses. Now, understanding properties of radicals is because if you have a multiplication in here, you can actually separate the two multiplications in their cube roots. So it's really the cube root of 8 times the cube root of x plus 4. Because it's multiplication. I can't separate the addition, but I can separate the multiplication. Now, if you look back up at for the left 4, I have just x plus 4. This is when I would change the h value and I would get the negative 4. So that actually works with what we've already done. But then the cube root of 8 is a value which is equal to 2. So this is really 2 times the cube root of x plus 4. So now my a value is on the outside. What that tells us is that we have a vertical stretch of 2 because our a value is equal to 2. So technically we can rewrite this. So our equation because we have our a value is a positive 2, we would have y equals a positive 2. We have our cubed root. Our h value is negative 4, so it will just become x plus 4. Then our k value is minus 2, so it would just be minus 2 on the outside. So the question is really asking, is this the same or not? And again, talk about the transformations. We could say that the transformations are no reflect. There's a vertical stretch of 2. We went, change h, that's a minus 4, so we went left 4. And then we went down 2, which is the same as what we had up here. So if we were to graph these, and I'll actually graph them in two different calculators so you can see them. I'll get the 2 calculators, get them cleared out. In one calculator, in this first calculator, I'm going to graph the original one. So the cubed root, so math 4 of 8x plus 32, and then outside of it, minus 2. And then in this calculator, I'm going to graph the new equation we have, which is 2 math 4 cubed root of x plus 4, close parentheses, minus 2. Now I'm going to zoom out a little bit so you can see the graphs. I'm going to press graph on both of them. I'm actually going to press zoom 6 on both of them. So here comes the graphs. And those look like they would be in the same spot. So then that means that we did write them correctly and that these match each other. So then on here, because it's a cube root, we do need to have our key point. We still have our key point, which is our h and k. It was still that negative 4 and negative 2. And then we would go find the rest of our coordinates. So negative 4, negative 2. Negative 4, negative 2 is right there. So that will go in the middle since it's a cube root. Negative 4, negative 2. And then we would have negative 5, negative 4. Negative 12, negative 6. And then going the other way, going back to negative 4, negative 2, I'd also have negative 3, 0. And then 4, 2. So then graphing this, can't graph this one, negative 12, negative 6, but I can do negative 5, negative 4, negative 4, negative 2, negative 3, 0, and then positive 4, positive 2. So as you can see, this is actually going up at a quicker rate because it's actually a vertical stretch. So it's going up at a quicker rate. So I know that this is going to curve. And this will curve going down as well, but I know I can't graph that negative 12, negative 6, but I know it'll look something like that. So again, when you're rewriting a radical function, you want to see if you can factor anything from inside the radical. And if you can, then you can separate the two radicals at the multiplication. So this is 8 times x plus 4. So I can separate it at the 8 and the x plus 4. Then once it's in x plus 4, it automatically gives me, since it's just x plus 4, it'll give me my h value when I change my h value. And then we would have the cube root of the one number, which would just give me 2, and that gives us our a value. And then our k value is still always on the outside. So that's how you rewrite a radical equation from the original one, so you can get the transformations. Because now that we have our transformations, we can write it in function notation rather than have it look like this. Because that's an 8x, which is not a parent function. So the function notation here would be 2f of x, not 8x, but x. And then we'd have plus 4, parentheses, then we'd have minus 2. Because we have to have the function notation of f of x, not f of 8x. That's why we want to make sure we can get our a value so that we have it in the correct function notation.